Welcome to the Explainer. I'm really excited to get into this one today. We are actually going to skip the traditional agenda entirely, because honestly, I just want to jump straight into this incredible, hyper-local mystery. It's a story that perfectly captures the hidden, physical realities of our digital world.
So where exactly does the internet live? We use these airy words like the cloud or wireless, which kind of makes our digital lives sound sleek, weightless, and, well, totally invisible. But here's the reality. Every single photo you store, every AI prompt you type, every video you stream, it all has a gritty, heavy, and very real physical footprint.
Okay, let's dive into this. Imagine a quiet neighborhood called Rolo Drive in Elk Grove Village, Illinois. Just recently, 55 families there quietly packed up their entire lives and left forever. Why? Well, a developer representing the tech giants that power the internet and AI came in and bought them out, paying about $1 million for every single home.
And the scene they left behind? Honestly, it's downright spooky. You've got 55 families completely gone. Houses abandoned right in the middle of renovations, basements flooding, children's toys, family photos, clothes, literally just left sitting there in empty rooms. The local rural fire district was completely dissolved. The people who lived there basically just got exhausted from fighting the constant rezoning pressure from warehouse developers. So one day, it's a thriving working-class neighborhood, and the next, an absolute ghost town, all completely leveled to make room for massive data storage warehouses.
Section 1. Ghost Towns of the Cloud. Now, what happened in Illinois is absolutely not an isolated incident. The massive, rapid expansion of our tech infrastructure is physically erasing and disrupting neighborhoods all over the country. Dad, there's a spaceship outside. That is literally what Carlos Jonas's 7-year-old son told him after waking up from a nightmare. They live in Prince William County, Virginia, and that spaceship the kid was so terrified of, it's a massive, sprawling data center campus that was constructed right next door to their residential neighborhood.
See, the cloud is something you can actually feel and hear. Families living next to these server farms have to deal with a constant 24/7 engine-like drone from the massive cooling fans. It's wild. Carlos Jan has actually spent $20,000 on new windows and insulation, and he can still feel the vibrations running right through his solid bedroom walls. The natural ambient bird songs, completely drowned out by these 75-foot-tall windowless warehouses right next door.
Section 2. The Thirsty, Noisy Neighbors. Shifting our perspective from that micro-neighborhood level to the macro-national scale, man, things are moving incredibly fast. America's exploding data infrastructure is staggering. Back in 2010, the U.S. had around 300 major data centers. Fast forward to 2024, and that number exploded to over 1,240. Virginia's data center alley, which we were just talking about, is now so dense it handles up to a third of all global internet traffic. And as we look toward 2028, the immense computing power needed to train AI models is driving an unprecedented spike in new construction.
Now, what's really interesting about this slide is how we can put these massive, abstract resource strains into a human-scale perspective. A single large data center campus can consume enough power to light up 200,000 homes. Think about that. And water? They can use 1.83 billion gallons a year. That is the water usage of the entire city of Santa Cruz, California. And what do local communities get in return? Well, despite eating up hundreds of acres and getting huge tax breaks, these highly automated facilities typically provide fewer than 150 permanent local jobs.
And there's a really surprising geographical reality to all this. Despite needing hundreds of thousands of gallons of clean drinking water every single day just to cool the servers, 43% of the largest data centers are actually located in areas of high or even extremely high water stress. Tech companies are flocking to places like the drought-stricken Arizona desert, mostly to take advantage of cheap land and tax incentives, and they're drawing heavily from already depleted sources, like the Colorado River Basin. It creates this intense contrast. On one hand, you have big tech companies marketing their commitments to net zero emissions and being water positive. But on the ground, the reality of maintaining the power grid is way more complicated. Take Nebraska, for instance. To meet the sheer spike in electricity demand from a new data center campus, local public utilities actually had to go back on their green promises, postpone the closure of 2 old coal-fired power plants, and plan for new natural gas facilities. The demand is quite simply outpacing the clean energy supply.
Section 3. Global Manufactured Landscapes.
Let's zoom out even further now. looking at the global and philosophical scale of the physical aftermath of our modern conveniences. The renowned photographer Edward Burtynsky has a great term for this. He calls them manufactured landscapes. These are massive, intentional industrial incursions and complete physical transformations of the Earth. We rarely see them, but they're created entirely to support our everyday human existence, our consumption, and our seemingly endless digital appetites.
And this brilliantly illustrates the sheer, staggering scale of global industrialization required just to feed our everyday lifestyles. To power our manufacturing and tech, the Earth itself is physically altered. Like, to build the Three Gorges Dam in China for hydroelectric power, 13 full-size cities were demolished by hand, and up to 2 million people were relocated. Burtynsky has photographed mind-blowing things, like a single massive fire in California containing 45 million discarded tires, or a single shoe factory in China employing 90,000 workers under one roof. The scale is just massive.
So, what happens when all our technology finally reaches the end of its life? Well, it's actually a pretty shocking statistic. 50% of the world's discarded computers and hardware ultimately ends up as e-waste over in China. And trust me, it does not look anything like the pristine, glass-walled aesthetic of Silicon Valley. The reality of where our hardware dies is incredibly gritty. We're talking about cottage industries, sometimes operating right on people's front porches, where circuit boards are literally heated over coal briquettes. Workers use pliers to manually pull off components just to extract the precious metals inside. The sensory reality there is a heavy, toxic smell of burning plastic and metal that you can smell for miles before you even reach the town.
Section 4. Our heavy digital footprint.
So, what does this all mean for us? What is our collective role as the consumers driving this relentless tech expansion? I love this quote from Edward Burtynsky because it really hits the nail on the head. He talks about the concept of attraction versus repulsion. We are totally attracted to the conveniences of modern life, right? We want the shiny new smartphones, the instant shipping, the mind-blowing capabilities of AI. But there's a massive consequence out there. A terrifying physical cost that requires digging into the earth, draining water, and displacing entire communities.
And the crazy part, this physical footprint is really just beginning to accelerate. Back in 2023, data centers consumed about 4% of total US electricity. But with the AI boom, and keeping in mind that AI requires vastly more power and cooling than traditional computing, that number is projected to skyrocket to 12% in the coming years. So I want to leave you with a lingering question. As we demand faster internet, more storage, and smarter AI, are we truly ready to pay the real physical cost of our digital convenience? The next time you save a file to your invisible cloud, just remember the roaring fans, the thirsty cooling towers, and the transformed landscapes that make it all possible. Thanks for joining me for this explainer. I really hope it gave you a whole new perspective on the very physical world behind our screens.